Paper 2, question 5. We're going to go to calculator page, and we're going to make sure that we can type in this expression. So it'll be x to the power of 4, move out of the power, plus 64 is equal to 0. Obviously it doesn't know what x is, but we're going to try and solve that. So what we can do is I can go to Menu, Algebra, we've got Polynomial Tools, and we've got Complex Roots of a Polynomial. We're going to be looking for complex numbers here. So it pulls up the cpolyroots command. I can just press up, up, and enter to paste that in. But because I'm after roots, I don't need to have the equal 0, and I can just solve this for x, and it gives me all the answers I'm wanting. Now, it's got them in a big long line there. It might be easier for me to just extract each one out at a time. So I'll call each of the solutions x1 through to x4. So x1 is defined as being equal to, and I can just paste in that expression and then do square brackets. Square brackets are controlled left brackets and do 1, and that will take out the first element of this list of -2 subtract 2i, and there is -2 minus subtract 2i for x1. Let's do the same process. I'm just going to edit. So it says x2 and take out the second element, and whilst I'm at it I'll just do x3 and the third element, x3 and the third element, and x4 and the fourth element. Alright, so you can see that we seem to have complex conjugate pairs. x1 and x2 are complex conjugate pairs, and likewise x3 and x4 are complex conjugate pairs. So let's just focus on the first two complex conjugate pairs. Multiplied together should give us a quadratic. So I'm going to do f1 of x is going to be defined as being equal to, open brackets, x minus x1 multiplied by x minus x2. And this expression will give us a quadratic from the first two complex conjugate pairs, and we can see where this takes us. Now, if I have a quick look at the graph, let's go to Control Document to insert a page. If I just press up, you'll see that F1 is already populated with that information, and you can see that I do indeed have a curve here, and it's the equation of this quadratic that I'm trying to find. Now, there's a slight problem here. If I try and just do the graph of y equals x squared and drag it over, I can get something pretty close. Seems to match quite nicely, but it's in completed square form, and I'd rather have it in expanded form. So this isn't really helping me very quickly get at the equation of this quadratic. So a nice useful trick we can do. Let's insert a new page, and we'll go to Lists and Spreadsheet. Now we're just going to type in the numbers 1, 2, 3, 4 and 5, and these are effectively going to be x values. I'll call them xv, and I want to work out the function values. I'll call it fv for all of these, and I'll say I want it to be effectively f1 of x, so I'll press var and do f1 of xv, the x variables, and I get these numbers here. So I'm just going to basically plot 5 points and fit a regression line to it, and hopefully fit a quadratic equation line. So Control Doc takes me to Data and Statistics. I'll plot my x values against my function values. I get a curve as expected. I now press Menu, Analyze. I'm going to fit a regression line of a quadratic, and I have the full equation of the quadratic of 1x squared plus 4x plus 8. So that would be one of my quadratic polynomials. What I can now do is I can go back and get the other one. So there'll be 1, 4 and 8. Let's just go back to my calculator page and make a note of that. So x squared plus 4x plus 8. So that's going to be one of my expressions. And what I'm going to do is I'm just going to redefine f1 of x now to be the other two complex conjugate pairs, x3 and x4. Everything should be updated as a consequence of making that change. So let's just go to the next page. You can see that the black curve has moved to a different location. I can move this over and we can try and again see that it doesn't give us in the form we'd like. All my numbers there have changed. The regression line here has changed as well, but the equation is 1 negative 4x plus 8. So I just go back to my earlier page, and so it looks as if my second expression would be x squared negative 4x add on 8. So the original quartic x to the power 4 plus 64 when factorized into two quadratics should be the expression on the page there. Now we don't know if this is true, but let's see if we can find a way of checking to see if our calculations have been correct. What I'm going to do is I'm just going to define that to be p of x colon equals, so my polynomial in terms of x is that, and I'm going to see if that has the same curve when I plot it as x to the power 4 plus 64. So let's go to a graph page, control doc, go to graph page, and I'll type in p of x. So that's what I think it worked out to be. I can't see anything on the screen, maybe the numbers are too big, so I'll just rescale round, and unsurprisingly we've got something happening there. Just change the x-axis, and you can see that that is looking rather like x to the power 4 plus 64, but the proof will come if I type in x to the power 4 plus 64. Whoops. Plus 64. When I press enter, sits exactly on top, which is very satisfying. I can also press Control T, and I can see that the values for f of 3, which is my two quadratics, match my values for x to the power 4 all the way down. So we've got lots of numerical evaluation seemingly showing that these two expressions are indeed the same. So we've completed the question. We're done.